I said, I don't have one of the nice ones that I can write all over the place. Hopefully this will work for us for today. The objectives. We are working with systems. We're starting the unit. It's all systems. Today you should be able to decide whether an ordered pair is a solution to a linear system or not. I think we already know how to do that one, yes?
Yeah.
Okay, so maybe I'll do a couple sections. We're supposed to be having them done in 1 week. You got to solve system by substitution, by addition, identify whether system has exactly one ordered pair solution. Sorry, systems that do not have exactly one ordered pair solution. Solve problems using systems of linear equations. So I'll give you guys a few seconds to write those down. Salud.
Do we still have early release tomorrow?
Yes, there's still early release tomorrow. Okay, can I change the slide?
No, go ahead. I'm just gonna go on your live.
Okay. All right, cool. So, all the equations that are in this form, please write, please write. Yay, it wrote. So, the equations in this form, the ax plus by equals c, are lines. They're straight lines when you graph them. I think everyone knows that you can stitch those around, put those in mx plus b form. They're just lines. And I know they're lines because x is to the first degree. First degree. And of course, y is also so. I'm not going to get anything funny that's going on. These are called systems of linear equations, or you can call them a linear system. And it should always have two variables in there. Okay? There's two types of these guys. There are something that's called a consistent system. And a consistent system has? No, it has one solution. It has at least one solution. So if it can be solved, and you get a solution, then it's called a consistent system. If you can't solve it, then we would call it an inconsistent system.
Well.
Thanks, Captain Olive.
Whoa. Hold on. You know, I really am going on this live.
Are we good here?
No.
Thanks for not having your laptops open or your cell phones.
My cell phone is being used for a great purpose. To watch your live once it connects.
Should connect already. Okay, so before we go on to the next slide, if I had a solution to an equation, how can I check if that solution? What do? You plug it in, and then when you plug it in, you should get some type of statement at the end, right? And that statement should be true. Make sense? Now, if you have a system, thank you for your professional courtesy. So if you have a system like this, and they're saying, hey, you know what, I think I have what's called a solution here. How do I check it? I'm going to plug into the top one or the bottom one? Both. I must check it on both. Because solution has to work for both. So 2 times 1 minus 3 times 2 should give me negative 4. Let's check that. I've got 2 minus 6.
Hey, look at that.
Does negative 4 equal negative 4? Yes, so it works for the first one. I'm going to check it on the second one. 2 times 1 plus 2 should give me 4. 2 plus 2 equals 4. Does 4 equal 4?
Yes.
Then this is a solution to the system. Yes?
Can we use like matrices?
Right now all we're doing is checking for solutions, right? Okay? questions here? I can change the slide.
If you plug like the second one into the first one and then you put the coordinates in, is that what you?
No, what you need to do is you need to plug that coordinate they gave you into both of them separately and make sure it works. We're not solving system here. We're just checking if this is a solution.
How do you not get in the picture?
My camera's not on.
Oh, makes sense.
Okay. I can change the slide. Oh, look at all that math in the back. Keep going. Is that the same thing still? Oh, it's again. So here, let's have you guys check this out. Try it out. Go, go, go. No, don't sing that song.
Yeah, please don't.
Someone told me they didn't know what that was.
What is it?
It's called Shenanigans.
Oh, I thought
The
you
Baby Shark song. They're like, what is that?
Do you know they made a Mexican version?
Yo, that was
They've
so
made lots of Mexican versions.
funny. I love that one. It's a mariachi.
No, it's banda. Mariachi or strings, bro.
If you want to get a song out of your head, think of an ending. And if you don't know what the ending is, you would think of a random ending.
What about tan tan?
What?
You would get it. The only people laughing.
Isn't this the same one? They just gave. Oh, no.
Yeah, because 2 times 7 is 14. It's not equal to 4. So it's not.
Is this a solution?
No.
But it worked for the top one.
No.
Top one, yes. Bottom one, no.
Yeah.
So
It's not a solution.
it's not a solution. All right, cool. Let's move on. If you want to read this, go into Math Lab and get the presentation on that. This is just giving you a method for solving systems by substitution. I'm going to just show you this real quick because you should already know substitution. You should already know this. So the objective of substitution is to get one equation.
Oh.
You get y by itself.
I got it.
Thank you. We're trying to get one equation to plug into the other. So in this case, I can modify the second equation to be y equals 1 minus 2x, correct?
Yeah.
What's nice about that is now I know what y equals. What does y equal?
1 minus 2.
And I can take that value and plug it into the y in the other equation,
Yeah.
which is substitution. So 3x plus 2 times y should be equal to 4. We said that y has a value of 1 minus 2x. At this point, we're just going to solve it because now we have one variable. So I don't know if I mentioned this. Something to know is that if you are trying to solve equations or systems, the number of variables should dictate to you the number of equations you need. What is this, 4x? So, I mean, if you have only one equation and you want to solve it, it should only have one variable. If you have two variables, then how many equations do you need? 2. If you have 3 variables, 3 equations, and so forth and so forth. Otherwise, you're going to get stuck in a loop. So what do we have here? Negative x is equal to 2. Therefore, x is equal to negative 2.
What did you plug that into the y?
Yeah, so to get your y, you're going to come over here where y equals. So y equals 1 minus 2 times negative 2. Therefore, y is equal to 5.
Yeah. It's negative 2, so you would get 1 minus 2 times negative 2, which is 4.
Question, since I solved it, should I check this?
Yeah.
You should still check it.
Wait.
You should still check it. What's up, boss?
So then you would just plug it in.
Hi, Lily.
Oh yeah, never mind. Is she watching?
I don't know. But if she is, and she probably will. And
She's gonna watch it.
pew 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 pew.
Let me check. She was texting me earlier.
Okay, so I'm gonna double check this. I should get. Let me do some green here. 3 times -2 plus 2 times 5 should give me 4. So I've got -6 plus 10 is equal to 4. Does 4 equal 4?
Lisa, hi.
Yay. Ah, funny. All right, and then on the second equation,
Yeah.
we've got 2 times -2 plus 5. That should give me 1. I've got -4 plus 5 equal to 1. Does 1 equal 1?
Yeah.
Yay. So my solution, and please don't leave your solution scattered like I just did. You need to come back because the solution to a system
OMG.
is an ordered pair. If you don't give it to an ordered pair, then you fools, you're wrong. You just lost points.
You fool.
Huh?
I said that to my brother without
Any context?
like
He said hi.
he
She
was
said
playing
hi.
like Minecraft or something and he did something wrong and I was like, you fool.
All right. Can we change the slide? All right, cool beans. Okay, now this other method is called, still going. I'm going to skip this. Is that cool with you guys? Because we've seen that. Next one is called, thank you for your professional courtesy. Next one is by addition. I think you've probably heard this called other things. That you might have heard this called elimination or
Oh, yeah.
linear combinations. They say all the same thing here. So here's what you're going to do with those. We really are trying to just get rid of something here to begin with, whether it be the x's or the y's. And this part of it you can only learn by practice. In this case, I'd want to get rid of my x's because I know that I can multiply this bottom equation by -2, which would give me an equivalent equation that reads -4x minus 6, not negative, thanks people, plus 6y is -14. And what I'm doing in this case, I'm not even paying attention to this equation anymore. I'm using the equivalent that is -2 times smaller. That doesn't sound right. That's a double negative. That's 2 times smaller than the other. Okay? So, now I can add the 2 equations. 4x, take away 4x is gone. 5y's plus 6y's gives me 11y's, and that should be equal to -11. And I can see from that that y is going to have a value of -1. Now I can take that y, plug it back into one of the first, into one of the first equations. I'll just use the one that's still exposed here. So I should get 4x plus 5 times -1 is 3. This is -5, so I'm going to add 5 to both sides. Therefore, 4x is equal to 8. X is equal to 2. Yeah?
Isn't that, yeah, it is a good one.
You still want to check your work.
Lost.
There's nothing better than checking your work because if it's wrong, you definitely don't want to plug that to MATLAB on your test, right?
Get rid of one of the variables. So the only one you can really get rid of by multiplying it by.
Why did I use a -2? What do you mean easier?
Oh, they multiplied the
Because I want to get rid of the x's. So when I multiplied, did I do that too fast, guys? I hear a lot of talking going. So let's just do it again. I'll slow down. You got to tell me, man.
Oh yes, you should have slowed down.
Thanks.
You're welcome.
So, elimination. They call it addition. We are adding equations. Obviously, you saw that I added the 2. I call it elimination because that's what we're trying to do. So we're really trying to get rid of one of the 2. Okay. Now, the only way to get rid of something is by adding it to its opposite. Correct.
Yes.
So, I know that I can do whatever I want to an equation as long as I do it to both sides, right? So the idea here is that if I can get this 2 to become a -4x, when I add 4x and -4, then they would make 0. That's kind of the idea behind elimination. So how do I make that happen?
You multiply by -2.
Yeah, I've got to multiply by -2, and that's why I chose -2. So now if I do it to 1, I got to do it the whole equation, right? So this would give me my -4, this would give me a positive 6y, and then finally I would get a, not a -4, but a -14. Okay? So for this process, I'm not using the original anymore. I'm going to use an equivalent of it, which is 2 times smaller. Now I can add the 2. So 4x take away 4x is gone. Then I've got 5y and 6y gives me 11y. And then 3 plus a negative 14 will give me a negative 11. I'll just go ahead and finish by dividing both sides by 11. Therefore, y has to have a value of negative 1. Okay? And to get the x, I just got to plug this back into, it doesn't even matter which one I use. Here, I'll try the second one this time, okay? So I've got 2 times x minus 3 times negative 1 is equal to 7. 2x plus 3 is 7. Take away 3 to both sides. 2x is equal to 4. And I see that x is equal to 2 again. So it doesn't matter which one you pick, you'll get the same thing. Right? Pick one you? Alright, cool. Questions on that? Okay. I just got the question right now. All you really care about is solving the system. So if you want to use a different method, like using matrices, and if you haven't seen it, then I'm going to show it to you. Pretty cool method, really fast. And it's using, if you're going to do with the matrices, you're using the determinant. The determinant. Determinant. I believe that's how you spell it. I wasn't going to show this, but someone brought it up, so I'm going to do that for you guys real quick, okay? Now, I understand that everybody already had Algebra 2, and probably everybody knows that you can throw that into a graphing calculator, but here's the problem with that. You make a mistake on there, you don't show me work, there's no way you can get points back. Okay, this is all about the work. So if you want to see this other matrix method, I'll show you right now, which is really, really cool. I don't know if you guys have ever seen this. You guys ready? Okay. Show me, eh? Okay, so I don't want to do that. I'm going to use bars. Is that cool with you guys? I'm just going to use a couple bars. So I'm going to take all the coefficients from this. You guys cool with that? So this will have a 4, a 2, a 5, and a negative 3. Simple enough? Okay. What? Are you okay with that? It's difficult. What's that product? It's negative 12. And I'm going to take away 2 times 5, which is 10. So what's negative 12 minus 10? Negative 22. Okay, we'll leave that there for now. Cool? You guys cool with that? I'm going to change this real quick. I want to make another matrix here. And this time, I'm going to put the answers in for the x. Is that cool? So I'm going to put a 3 here, 7 here. This would be a 5 and then a negative 3, correct? And I'm going to call this one x equals. You guys cool with that?
So your y's go on the right side?
Yeah, the y's are staying the same. All I did was trade the x's for the answers. These answers. And I'm going to do that again. So it's going to be the difference of the two products. So this is negative 9, and this is negative 35. So what's the x equal to? No.
No, it's positive
Positive
35.
30. Wait, yeah, it'll be positive 35. So
So negative 44? Negative 44?
yeah.
Okay, I'm going to do it one more time. Guess how this one's going to look?
Again?
It's gonna be the D and the X on
So I'm going to put, what's going to go in the x?
the
4 and 2? No. I did that backwards, didn't I?
3, 7, and 4, 2.
Oh, no, these are the answers. These are the answers, right?
Yeah.
All right, so then this should be 4, 2, and then it should have 3, 7 there, right? Cool.
So you kept the x's
Oh, so
and
you
then
just have
Yeah, so all I did here are the answers with the x's. These are the, those aren't the x's.
put in a y.
Sorry. These are the y's. And then these are the x's, and then the answers are here. So it's kind of like the first one, except I traded the answers for the other column. Does that make sense? Okay, so let's do that one more time. I'm going to call this y. Cool? So what's 4 times 7? How much? 28. And then that? 6. So the difference is 24? 22. Positive? Okay, check this out. So, was any of this work hard? No. Here's how the answer will show up. It will be x divided by d and y divided by d. So, what's this divided by that? 2. And what is this divided by that? And there's your solution again. So there's another method. I don't think anybody see that method before?
No, I haven't.
College? Yeah, that's where they'll show that to you. So it's a really cool, easy method.
Is that just how it works in the calculator?
No,
Just,
no, the calculator does row operations. Calculator does row operations, which is also something they teach you. Oh no, we did it last year. No. I think we might do that in this chapter. I might have jumped the gun. Maybe this was a lesson, but you know what? If I need it now, right? Kind of thing. Isn't that cool? And I'll show you how to do it with 3 by 3 later on. What's up?
Right.
All right. Right here. Take x divided by d, and then y divided by d. And they're right here, all of them. Okay. I'm not sure why they don't show this method. This is a really fast method. I like this one a lot. All right, can we move on? Okay, we won't. Ay, ay, amor. How dare you disrespect Don Vicente Fernandez? All right, we're good now?
Yeah.
Okay, cool. Let me move on.
Yes, sir.
Okay.
Yikes.
Move through, move through, move through. Move through, move through, move through.
Done. Right.
Here we go.
Here we go.
So, here are, I guess, 3 of the 4 scenarios. Well, actually, these are the 3 of the 3. The lines can cross one time. It'll be in some form like this. Of course, the lines can bend any way you want. Right? You guys have seen them, correct?
Yeah.
They only cross one time. One solution, right? In the middle, you've got 2 lines that are parallel. So how many times do they cross?
None.
Never. They'll never cross because they're parallel to each other. Therefore, what type of system? Inconsistent. The first one was?
Consistent.
Looking over here at the last one, this is called a coinciding system, right?
Yeah.
It's where the lines are the same.
Oh, yes.
So, coinciding system and consistent or inconsistent? Consistent because it has
Everything.
at least one solution. But this one has infinitely many solutions. Cool?
No, don't.
I'm not changing it. Commentate. cheese.
We're supposed to have tostadas for dinner tonight. Ooh, have you had the
I can change the slide
you
now.
know that one?
Okay.
It's similar to.
Thank you. I'm gonna make this part really short for you because you already know. You obviously already know how to solve a system. But here's how you tell the difference. Muchas gracias. If you have a system that is inconsistent, I hope I spelled that right. Once you get to the end of something, you're going to have a false statement of some sort. Like 0 equals 15. Does 0 equal 15? No. So that's going to tell you that you have an inconsistent system. Okay? So you're not going to get like x equals something. It'll be something more like this, where the two things is just bleh. Now, in order for it to be consistent, you should get a true statement. Maybe something like 5 equals 5. 2 equals 2. X equals x. As long as what you end up at the end is true, then you have a consistent system. Versus a false statement, inconsistent system. Make sense? Okay.
Crank the heater.
No, there's only 2 types. This one is consistent. This one is inconsistent. Okay? Alright. Okay. We're good? Whoa, what that?
Are we done?
Nope.
What? 2.2?
It's the same as the last one.
It'd be combined
Okay.
homework.
Yeah. So 7.1 is 2 by 2s. 7.2 is going to be 3 by 3s.
Are we still live?
Yes. So how do we solve a system, or sorry, how do I verify that the solution given to us is the solution to the 3 by 3?
So is this
Plug 'em into
7.2?
This is 7.2 now. 3 equations, 3 variables.
Yeah, but what is that?
This is,
X, Y, Z.
yes, we always put them in alphabetical order. Well, now it's
Where's the Z?
Sunny Low. We're moving on behind algebra 2 to trig now. So we're going to up the antes to 3 by 3s.
Is it like three-dimensional?
No. Well, yeah, actually it is. You're correct. Yeah, if we have a 3 by 3, that could be considered 3-dimensional.
I don't think you can plug this into a calculator.
Not if you, unless you have an Inspire with 3D on it. Yeah, so you'll have something like this, but then you'll have an axis that kind of cuts through. 4-dimension. Okay. How can I verify if this is a solution to the system? One more time. Plug it in. Should it work for 2 of them?
All
It should work for all of them. Do I really need to show you how to do that?
No.
I didn't think so. Well, let's move on. So yeah, they're plugging in. There's one, there's two, and here's a third one. It worked, so yes. Let's move on. This is called an ordered triple.
15 times 3.
Okay. Solving them. I'm gonna need my smart.
So for this one, you do have two equations?
Nope. Nope.
Do you still use that same method they taught us before?
Yeah. All of the methods that you've used here work for this as well. I wouldn't advocate for substitution too much, but I'm going to show you how to solve them the way I would. Okay. So let's take a snapshot from Progressive. Okay.
Meaning 3 variables.
So here we have system, 3 equations, 3 variables. Okay? I'm going to show you how to solve them probably 2 ways here. I don't know if the other way is the way that you want to do it. It's totally up to you. Pick one, get good at it. Alright. So for here, what you're going to have to do is you're going to have to group them first. So take a look at those. What's your intuition tell you we should get rid of? Z's, huh? Good. Because remember, we're gonna do elimination here. So if these kind of cancel each other out, and it'd be pretty simple, just double the other one, right? So I'm gonna use the top one twice. So I'm gonna start by setting up 3x plus 2y plus z is equal to 8, and I'm gonna compare it with the first one. Okay? And then I'm gonna take the third one, 2x minus 3y plus 2z, and I'm going to pair it with the first one again. You guys cool with that?
No.
No?
What equals 8 on the first one?
What's it supposed to say? Oh, equals 20.
Oh, okay.
No, we're not cool with that. Thank you. That would have been horrible. So someone verify that I wrote these correctly? We're good?
Yes. Yeah.
All right, cool. So we said we were going to cancel z's. So here they're gone. I've got 4x plus 6y is equal to 28. Okay? Let's go over to the other side now. In order for me to cancel here, I'm going to have to double this one, aren't I? Multiply by 2. So that will give me 2x plus 8y minus 2z is equal to 40. Right? Everyone okay with that?
Yeah.
All right, I'm going to add them up. 2x and 2x is 4x. Negative 3y plus 8y is positive 5y. And the z's are obviously opposite. And then what's the difference between 16 and 40?
24.
24?
Yeah.
Cool. So here's the 2. You will be tested on this. And maybe it would be all 3x3s and not 2x2s. So I would want to pay attention. So what I have with those 2 is now a new system that's a 2x2. And I can use my whatever methods I want here. The easiest way would be to just change the signs right here, right? So that becomes negative, negative, negative. So this is gone. I've got y is equal to 4. So now that I have y equals, I'm going to plug back into one of the first ones that have the 2 equation, 2 variables. Top and the bottom one, does it matter? No? I'm going to take this one, okay? So I've got 4x plus 6 times 4 is equal to 28. I'm going to take away 24 to both sides. That's an ugly 4. I saw it coming. So that's going to be gone. So I got 4x is equal to 4. Therefore, x equals 1. Now that I have x and y, I'm going to go to the top and pick one of the original functions. And I'm going to try to squeeze it in here somewhere.
Just do x.
Which
plus
one?
The
That
x
small
plus-
one, huh?
Yeah, x plus 4.
This one right here?
Yeah.
So x, which is 1, plus 4 times 4, which is 16,
Yeah,
minus z is equal to 20.
Yeah.
So this is how much here? So I'm going to take away 17. So negative z is equal to 3.
Yeah.
Sorry. I put a negative in there, to 3, therefore z is equal to negative 3.
So then we would plug those into each equation, right?
So my solution is 1, I'm saying my solution is 1, comma 4, comma negative 3. And of course, you want to verify that that's true. Plug that back into...
You could just use a calculator for that.
Yes, you could use your calculator, but again, if you make a mistake, and I'm not saying don't, that's what I'll be going for. But I'm checking, double checking, I'll put everything in right.
If you were gonna do substitution, would you make like
You wouldn't use substitution. It would be just too crazy. But you could. And if you want to know, I can sit with you and show you that. But I think substitution would just blow our mind.
Oh, I didn't know.
Substitution will be much fun. Yeah, let me
gonna break your own break?
You look so angry when you're taking a picture. I put my foot down. Alright. I got one more method to show you. What's up?
So you know is there underneath the 4x plus 6y plus 28?
Yeah?
Underneath the 4x plus 5y plus 4
Equals 24? I got it from the red part. That's why I color coded it. It came from this piece right here. Yeah, see, if you combine this equation and this equation, what's 2x plus 2x? 4. There's your 4x. Negative 3y plus 8y is your 5y. And then negative 16 plus 40 is 24. Because the z's cancel, don't they? Okay? All right.
Munoz, those were the right answers.
They were? Yay, me! Pat myself on the back.
Oh, so you just
Okay. Raise your hand if you're a little patient. Hey, those of you that are not will probably not like this method. Well, actually, you know what? Let me take that back. How many people like the method I showed you with the matrix? For the 2x2. Okay, cool. That's the other method I'm going to show you here.
Oh, great. That'll be fun. Not really.
Okay.
It's just gonna be longer because of Nuna.
It is. It's exactly. It's just going to be longer. It- okay. So now here's the deal. Here's the deal. Dilly dilly. Here's what the solution will look like. So I'm going to kind of use what I did before, so you can kind of have an idea of what I'm going to be doing right now. Okay. We're going to make how many matrices this time? 4 of them. Last time we did 3, right? We did D, we did X, and we did Y. So we'll do D, X, and Y, but we'll also do Z. The solution will come in this form. X over D, Y over D, and Z over D. Okay? So it's all the same. Same method. Here's the deal. Here's what's wrong with it, though. I've got, what is it? 1, 3, 2, 4, 2, negative 3. And then I've got negative 1, 1, and 2, right? Okay. Here's what I want to do. Yeah, we're going to find the determinant first here. Okay? Remember what I did? I said this minus this. Same idea?
Wait, how do you multiply that?
Well, let me show you. So you might want to watch and put your pencils down because this is going to get kind of highlighter. Okay, I'll use the yellow. I'm going to multiply these 3. Remember how before I multiplied the 2? I know, huh? That's not bad, though. So what's 1 times 2 times 2? 4. Plus. Wait a minute. Here's my problem. I need 3 numbers, don't I? And this one is missing 1? Does everybody see that?
It'd be 0, right?
Here's what we're going to do. The first 2 rows, we're going to copy them. So I'm gonna do 1, 3, 2, 4, 2, -3. Yeah, we're just repeating the pattern. You guys cool with that? I could show you the other way, which is really confusing.
And then it'd be 8, 4 plus 8.
So what do I have next? 4 times 1 is 4, 4 times 2 is 8, plus the next 3,
9.
-9?
No, positive.
Oh, yeah, positive. So this is 9. Okay? Now, for the other side, we're going to go the other direction. So here's my 3, right?
Yeah.
So what is that? -4?
Yeah.
-4. I couldn't save that 4. I'm sorry, I couldn't save.
Come on, now.
I couldn't save the 4. 4. And then what's the other one? So let me show you the other one. Here's that one, and then here's that one. Okay?
So you just do 3?
Yeah, it's 3 always. So -4. This should be -3, and then plus
4.
24.
Wait, whoa.
Yeah.
2 times 3 times 4. Yeah, 24. So what do we have?
21.
That's not 12.
21.
No, but the
It's
21.
21.
21 minus
Minus
17. Yeah.
minus 17.
Yep.
So that's how much?
4.
So there's D. Yay, we got one. So,
Wait,
do you guys remember what I did for the what?
Oh, God.
That's what I said. You might not like this one. It's just tedious.
Hope you know that.
Okay.
That's why. That's your why. I plugged this into a matrix.
4. Oh, sorry.
I already plugged this into a
Now,
matrix.
thank you. Intuitively, do you remember what we did with the other one? We wanted the answers for X, so we put all the answers in for X. You're doing the same thing. You're just replacing the columns and you're repeating this process. Okay, I can do it with anybody on Friday when I come back. For everybody else, you've got elimination, and you've got your calculator.
So we can do that just for the first part.
Alright,
First
thank you.
number, and then plug in.
Well, you're doing it again. You have to do it 3 more times. You have to do it now for X, Y, and Z.
I just plugged it into a matrix, so I got the answer.
Yeah. But again, and I'm not saying you have to do it this way.
Negative.
I'm not saying you have to do it with elimination.
It'll probably be
I'm just saying if you do it with your calculator and you put it in wrong,
Well, I mean, then you gotta read.
I wouldn't have said it that way because.
We will be very messed up.
All right, cool. All right, can I move on?
Yeah.
I think that's everything, right? Our 2 objectives were just to solve and check.
Yeah.
Yeah, and then use them, which of course you're gonna have to because it's gonna be word problems. So, there's your 2 sections. Thank you all.